All right, so I'm back to work on making this bracket for the Craftsman sander, and I've come to the point where this is the largest hole I can make with, well, this is the largest drill bit that I own that I can actually use in my mill. Um, I have larger drill bits. The problem is they're all Morse taper, and I do not have a Morse taper adapter that will actually go in my, the mill is R8, so I'd have to have probably a Morse taper adapter that has a straight shank on it, and then I could maybe chuck that in the in a collet in the mill, and then maybe I could use one of my Morse taper drill bits. Although that would be putting, I think now I'm kind of pushing the limits of how much torque I would want to be putting on a collet. I'm not sure about that, but anyways, then as far as chucks go, all of the chucks that I have for this mill, I have several of them. None of them will accommodate anything larger than this in a shank. I do have some pretty big chucks, but unfortunately those also have Morse tapers on them. So some of them I can use in the tailstock of my lathe. Some of them I probably can't use at all. And at some point I should just change the shanks on them to something that I could use maybe in the mill. Anyways, I haven't decided yet. So I've got to make the hole bigger. So the next logical thing for me, since to use what I have available to me, would be a boring head. So I have several boring heads. This isn't a genuine Bridgeport. I forget who makes this one. That might be a Bridgeport also. This is a no-name aftermarket Shars or something like that. It's got, I forgot what I figured out that was. That's actually, it looks like a nice little head. And then I get this little weird tiny one here. I forgot who makes this. This is really limited to what you can do with it. So that one's pretty much out. And then the problem I have with these, I do not have any boring bars that will fit any of these heads, with the exception of possibly I might have a boring bar that takes a carbide insert, which would be sweet, but I don't want to go through digging through all those things, finding a bar that's going to fit, then finding an insert, and then, who knows if the geometry is going to be right of the cutter tip or whatever. So I'm going to go with this Yugoslavian made one that I have. And the reason why I'm going to go with this Yugoslavian made one is because it's the only boring head I have that will accept these boring bars that I have. And it should work perfectly fine. Famous last words. So I've seen boring bars used, but I've actually never used one myself. So I have absolutely no idea what I'm doing. Well, I shouldn't say absolutely no idea. Like I said, I've seen them used. So, for instance, I know that the reason why there's multiple holes in this is so that it can be set up for different jobs. For instance, if you've got a much larger hole that you're boring out, you would put this in the outboard hole here. I think for the size hole that I'm dealing with, I'm going to want to have this in the inboard hole, so to speak. And then I'm assuming that because of the thickness of my piece that I'm going through, I don't need one of these long bars like this, and that probably the shorter the bar, the more rigidity I get, which should translate to a better cut. So I'm going to go with this shorter bar. Now, there's nothing on here that makes this positively engage. So obviously, whichever way I have this rotated when I clamp it is going to be, it's going to affect that angle. And again, I don't know for sure. I know that if I had this, for instance, in the lathe and I was going inside of a bore and cutting, that I would probably want this cutting edge right here pretty much horizontal. So I think that's what I'm going to do here. I know if I rotate this too far this way, that's really exaggerated. But if I rotate this too far this way, I run the risk of running out of clearance here. Now, if it were too far this way, I know on the lathe that can be a problem. I'm not quite sure what the effect would be in a boring head. So just to be on the safe side, I think what I'm going to do is I'm going to try and line this up as close to perfectly vertical as possible. Maybe a hair down. So right now, there may be somebody out there in YouTube land that is screaming at their computer screen or TV screen and telling me I'm doing this wrong. All right, so I tighten this down as tight as I can get it, and I know that the other adjustments are, of course, I've got this adjustment here, which controls how far in or out the boring bar is off of axis, which as it's rotating is going to determine the diameter. So for instance, if I bring this all the way in and I set this to, I don't know if there are any alignment marks on here, but if I set this to, I guess, 0, like that, then theoretically right now this would only bore a hole of this diameter of this cutter right here, and of course you can't really do that because this backside would be rubbing. So, but just to get an idea of the whole function of this thing, because right now if we were spinning this, this would be spinning in place. As soon as we start offsetting the head, this whole cutter moves over, so now it's spinning like this, going around like this, and it starts, you know, making the hole larger. So I got to put this in the mill, and then I got to bring this over, I guess, until I'm just touching off on the inside of that diameter that I currently have. That hole's not going to be perfectly round because I did it with a drill bit, so technically it shouldn't be perfectly round because it's not a reamed hole. So I'm probably it's going to probably rub in one spot and not in another spot initially. So that first cut's going to be uneven. And then if it were a perfectly round hole, theoretically, if I just touch off, it shouldn't rub harder in any one spot. If it did, that would indicate that maybe there's a problem with the boring head, that it's not, that the head is not mounted correctly to the shank here, the R8 shank, right? I don't know. That's, you know, why am I even saying that? I have no idea what I'm talking about. So I got 3 screws here that are almost like jib screws for this dovetail. And I'm making another assumption here that all 3 of these should be loose for adjustment and then tightened down prior to taking the cut. So I think, I'm not positive, but I think these are supposed to be locked down. Now, that means that every time I want to adjust the head, I've got to loosen these 3 screws before I can turn this. That sounds strange to me, but then again, like I said, I don't know what I'm doing. I noticed that on some of these heads, these things click as they go along. This one does not. So I don't know what to make of that either. So, well, what the hell? Let's see what kind of trouble we can get into. Let's throw this thing in the mill. All right, so what I ended up doing was I lowered the knee to get the boring head in. Then I raised the knee back up so I have enough clearance to get my part in here, so when I get close I can start doing test fits. I can just drop it in and see when it fits. That way I don't have to be dealing with a bore gauge and worrying about any error that way. So now I bring the cutter down so it's just below the edge of the top of the hole, and I'll lock the quill, and I'm just spinning. I'm going to spin it by hand. I'm going to adjust this just to make sure these are still unlocked, which I believe they are. All right, and I'm going to adjust this. Oop. until I just touch off. That's close right there. Just curious if it hits anywhere. No. So there we go. Just touching off there. Okay. All right. So now I'm going to bring this out of the hole, obviously. And I can look at my little graduations here on the side, and I can figure out how much of a cut I want to take. So, because I don't know anything about using one of these. I'm just past the 10 thousandths mark. That looks coming around 12 thousandths. So I think what I'll do is I'll go to the 25, which will be about a 13 thousandths cut. Because I have no idea on how well this thing's gonna behave. I'm gonna have to play with speeds and feeds. I have to be careful with that boring bar because I don't have a lot of them. I'm not set up right now to resharpen that. So, all right, let me get some safety glasses. So I'm just gonna spin this thing fairly slowly, and I'm gonna lower this by hand just to see how it cuts. So I think what I'm going to do is I'm going to engage my fine feed, my fine manual feed on this Wells Index mill. I love this about this mill. So for anybody who's not familiar with the Wells Index mills, I've got this lever right here. I just actually released it, but you'll see this is, you know, the manual quill that you have on the machine. And then if I engage this lever right here up so it clicks, it now has locked that quill to this lever right here. And this gives me a fine down feed. You can actually see when I'm turning this lever, it's actually moving this quill handle. Now, if I engage the power down feed, then it'll slowly move down, and that is actually this lever on the side here. And then there's different settings, different speeds. But I'm just going to use this manual. I'm going to manually use this fine feed. Should be getting close. There we go. So I'm going to bring that speed up a little bit. All right. Okay, that's a pretty horrible looking finish on that bore, but I'm not really concerned about that because I was manually feeding at a very slow RPM, so I'm not surprised that that kind of looks like okay. So I think 15 thousandths I was barely taking a chip, so I think what I'm going to do is I'm going to take 20 thousandths now. Let's take 30 thousandths, or try to. And let's see, I think I'm going to try and engage the power feed. finish looks a lot better. I think that's too fine of a feed for what I'm doing. Alright, so that's the bottom of the hole. Get this off before I stick my fingers anywhere near there. Oh, that feels nice. I could see some little lines in there, but I mean, it really feels like a nice cut. So I don't need that fine a finish right now. So I think what I'm going to do is I'm going to, I don't know if you noticed, but I'm still taking these very, very little slivery chips out of this thing. So I'm still not taking much of a cut. Let's leave the down feed where I've got it, and the speed seemed pretty decent. I'm going to take a larger cut. So that last one was 30 thou. That's 10, 20, 30, 40. That ought to be 50 thou. All right, I'm going to take another 50 thou cut, but I'm going to bring the speed back down just a little bit, and I'm going to increase the feed rate. Increase the feed rate. I get a feeling when you guys see this video, you're probably going to be like, oh, I don't know. I got a feeling you're going to tell me that I should be able to take a much larger depth of cut than 50 thou. All right, let's try 100 thousandths. Cripes. Seem to handle that no problem, other than making some downright dangerous swarf. Alright, so I just roughly checked the hole with the calipers here, and if I take another 200 thousandths off the diameter of the hole, if I enlarge the hole by 200 thousandths more, then this narrower side should drop into that hole. Now, if I'm understanding this correctly, this is how far I'm offsetting the head. So if I offset the head by 100 thousandths, because it's taking a cut all the way around, I'm actually I'm enlarging the hole by 200 thousandths every time I do that. So I'm going to set this for another 100 thousandths, take a cut, see if that drops in. If that drops in, then I'm going to reward myself by breaking for lunch. So that should be 100 thousandths right there. Additional offset, which should correlate to 200 thousandths increase in diameter of the hole. And the other thing that's happening is this swarf is getting stuck down in this hole underneath the piece. This stuff can be nasty sharp. Alright, noob. Alright, so apparently this is direct reading. Meaning that when I dial this 1,000, it's actually offsetting the head 50 thousandths. To take 1,000th, to increase the diameter by 1,000th. That's the only reason. That's the only thing I can think of to explain the fact that this will not go in this hole now. All right, after lunch I'll take a more direct reading and see if I can't confirm that. All right, so I just checked, and I'm actually I only have 16 thousandths more to go to this diameter, this minor diameter. So I'm still not convinced whether or not this is direct reading or not. So I'm gonna try and take 8 thousandths off and see what happens. That's interesting. When I tried to take that really light cut, it cut about a third of the way down, then stopped cutting, and then started cutting again. Huh. All right. Looks like I get the answer to my question. I needed to go 16 thousandths more. I took 8 thousandths off, and it fits right in. So this is not a direct reading. I dialed this over 8 thousandths, took 8 thousandths off on each side. That took off the 16 thousandths I needed to make that fit. Now I just need to know how much further I need to go to fit this diameter.